Thank you, Mr. Nambane. Good afternoon, colleagues. Hope everything is well. Right, we're going to start straight away with a technical science paper one memo discussion. So if you look into question one, we see it's multiple choice. I don't see anything wrong there, so we're going to leave it as it is. So if anybody has any questions, um, you can just ask. Thank you, sir. So at question two, grade 11 learners conduct an investigation to compare the development of plants placed in a fertilized and unfertilized soil. So the rate of development was monitored by measuring the changes in the height of the plants in weekly intervals. Week 1 to 5, height of growth in fertilized soil in centimeters. The data was given there. 1,5, 3, 4, 5, and 6. Height of growth in unfertilized soil in centimeters. 1, 1.5, 2, 2.5, 3. So the question was at 2.1. Draw a graph of height growth in fertilized soil versus weak. So if you look at 2.1, there's changes that we made into the memo that is highlighted in yellow. So the graph, it's supposed to be height in growth in fertilized soil in 5 weeks. The y-axis is height in growth in fertilized soil per centimeters. The scale is from 0 to 7. And then on the x-axis, there's number of weeks. The scale is from 0 to number 6, 1, 2, 3, 4, 5, 6. So it was the data was plotted, and the mark allocations will be number of weeks on the x-axis with the height in centimeters on the y-axis for 1 mark. Any 2 points correctly plotted for 1 mark. And if it is a straight line or direct proportion, the third mark will be given there. Then at 2.2, in which type of soil did the plants grow the fastest? Write only fertilized or unfertilized. The data shows fertilized because there's an increase of number of height of growth. Then at 2.3, you will also see at 2.2, there's also been changes made. So anything that is in yellow, the changes will be allocated or showed to you. At 2.3, what is the relationship between the weak and height of growth in fertilized soil? Write only directly or inversely proportional. The answer is directly proportional. At 2.4, give a reason for your answer in question 2.3. Both sets of x's is increasing with the same factor, or when the learners say when the rate of the plants increases, we award a mark there. 2.5, consider the data given for the unfertilized soil. 2.5.1, calculate the gradient of the graph. Gradient is m equal to the change in the y-axis over the change in the x-axis for 1 mark. Substitution, 3 minus 2,5 over 5 minus 4. You can even use any of the other data as long as there is a change of the y-axis over the change of the x-axis, and it will give you an answer of 0,5. Total question consists of 9 marks.
Good afternoon, colleagues. I just want to seek some clarity on question number 2. First, okay. First of all, if we go back to the graph there, I really feel like the learner should be awarded for plotting any points, because what about a learner who has the independent and dependent variable incorrectly? That means this learner is getting 0, because anyways, for learners to plot a graph for 3 marks is not even fair to begin with. So if we can please at least accommodate the learners there for any 2 points plotted, whether correct or incorrect. And then at 2.5, the question is saying, calculate the grade. Okay. Is you're going to penalize them already? That number of weeks being wrong. Yes, 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 yes. Mm-hmm. Yes, yes. And it's unfair to give a learner 0 for a graph. Mm, mm, true, yes. Yes, Manette. All right, thank you, Manette. All right, thank you for clarifying that, Manette. Thank you, Tati. 2.5? 2. Yes, ma'am. Okay, 2.5. Okay, now that, okay, with 2.3, is it also then going to be positive marking because directly or inversely proportional, they will get it from the graph? 2.3, is it also going to be it's negative marking? Okay, fine. All right, no problem. Uh, okay, okay. 2.5, it says calculate the gradient of the graph, but the graph requested is for fertilized soil, but now 2.5.1 is saying unfertilized soil. So now you're expecting learners to use the table to calculate the gradient. Is it correct, science? So why is there on of the graph? Mm-hmm. Yes, and they must calculate. Okay. Of the graph. No, Manyati, here it's written calculate the gradient of the graph. Which graph are you talking to? It should have then said calculate the gradient from the data given above, not graph. Okay, it's fine, Manyati. Then last time, all right. Then last time you said that if a formula is not given on the formula sheet, it doesn't have a mark. So why are we then giving a mark to the gradient formula? All right. Thank you, Tate. Thank you so much.
Can you hear me now? Joey. Okay. I will get back to the question. Is it fine now? Good afternoon.
Good afternoon.
Thank you. I think my question is almost based on what Mevia raised, because that other question said they must calculate unfertilized soil from the graph. So I have a learner who has a graph. The learner showed both fertilized and unfertilized soil on the graph. So how do I mark this learner from the graph? 2.1, the learner showed both fertilized and unfertilized. Yes, on the graph. It's one graph. Two, yes. Yes. Okay, thank you, Ntate Namban.
Thank you, sir. Question 3 at 3.1, it says define resultant vector. It's a single vector that has the same effect as two or more vectors together, two or nothing. So there will be no part marking over there. At 3.2, represent 60 meters and north 70 degrees east by means of an accurate construction. Use the scale 10 millimeters by 10 meters for 4 marks. So if you can move it up a little bit, so. There's a marking criteria that you must use. The first one is to see the clear reference line or crosshair, like north, east, south, or west. The length of the vector, you should actually measure it with 60 millimeters by 10 meters with a ruler if the child did not use a scale and showed it to you. The direction, if it's correct with the error, and acceptable labels with the magnitude and direction. 70 degrees must be there as well as the error. We move on to question 3.3. Two construction workers are pulling up a toolbox towards the roof of a building. One man pulls it with a force 10 Newton, while the other worker pulls it with an unknown force Q. It also goes along with a picture over there showing you what was said in the scenario. At 3.3.1, calculate the horizontal component and the vertical component of P. Horizontal component is the x-axis, which is F cos theta. 110 cos 40 degrees. You will see there's a correction with highlighted, and the answer will be 84.26 Newton. Vertical component is the FY axis, F sine theta, 110 sine 40 degrees as 70.71 Newton. You will see the formulas don't get a mark, but the substitution and the answer with a unit each get 2 marks, and then it equals to 4. At 3.3.2, it says calculate the tension in the row Q. You're going to use the formula of trigonometry. Tan theta equals to opposite over adjacent. The substitution is for opposite 84,26. The adjacent is the force, which is the unknown. And then the tan theta will be 1040 degrees, which equals F to 100,42 Newton. 1 mark for the formula, 1 mark for tan theta, which is 1040 degrees, 1 mark for 84,26 over F, and the last mark for the answer with the unit 104,42 Newton. At 3.3.3, determine the resultant of the horizontal components. Because of the changes in 3.3.1 and 3.3.2, it will also affect 3.3.3, 3.3.4, and 3.3.5. So the resultant of the horizontal components is 84,26 plus 100,42 cos 50 degrees, which equals to 148,81 newtons. 1 mark for the answer with the unit. Then we move on to 3.3.4. Determine the resultant of the vertical components. Mr. Nambani, can you move up, please? Thank you, sir. At 3.3.4, the resultant force of the vertical components will then therefore be 70,71 plus 100,42 sine 50 degrees, which is equal to 147,64 Newton. Then we move over to 3.4.5. It's numbered as such on the question paper, but it's actually 3.3.5, which is the weight. The weight of the toolbox is equal to mass times gravitational acceleration. Then the substitution will be for weight 147,64 and then equals to m times 9,8, which give you a total mass of 15,07 kilogram. The marks that are being awarded is for the formula, the substitution of weight, the substitution of mass times 9,8, which gives the substitution of the answer a mark with the unit. Total question consists out of 20 marks. Is there any? Okay.
Can you go up, please, Munyan? At 3.3.2, I think you have to rather remove that question because as we're doing Pythagoras within the limitations of vertical and horizontal component, mostly even on the ATP, you can check CAP's document, the tan continue. Man. Then to put that kind of substitution.
I can't.
Hello, Munyan? Oh, sorry. I was saying that at 3.3.2, at 3.3, yes, 3.3.2. Not 3.2, 3.3.2. Yes, Mania. I think it's unfair to put this 10 here for the learners, honestly, especially for 4 marks, because grade 11 works within the parameters of the vertical and horizontal component for Pythagoras theorem. So adding this 10, it's not going to benefit the learners of technical science at all. Okay, let me just check the original. Okay, it's fine. I will remember that and for grade 12 as well and use it as an alternative strategy. Okay, so Please next time add it in the question. Use trigonometric ratios to calculate the tension in the rope. Okay, thank you.
Ntate, am I audible?
You can hear you.
On the very same question, first question 3.2, clarity seeking question. On the marking criteria, it's the first time I see we have a marking criteria for clear reference line. I had Meraj explaining that they have north, east, south, west. Are we not disadvantaging our learners because it's the first time we add that criteria of a mark for a clear reference line? They usually just do a course and then the course will determine which quadrant are they using. Yes, that's number. Please, Ntate Nambane.
There must be a reference line. It's not necessarily that it must be marked north, east, south, or west. But the reference line must be there because how are you going to start to know in which quadrant it must be? So I don't think we must take that away, sir.
All right, thank you, Ntate Nambane. And then same question 3.2. 3.3.2, apologies, 3.3.2. I don't know, Ntate Nambane, because the last time we had a memo discussion about this question, I remember the other teacher was speaking on behalf of learners that are doing mathematics to say that we are disadvantaging learners that are doing pure maths because we are limiting them into answering only using cos and sine. And it was agreed that we are using cos and sine because we are using only the angle from the x-axis. And that's how we went back to teach our learners. But today, again, we are saying we are not limiting the learners. They can use any mathematical way of calculating. And then number two, I just all right. And then on the very same question, I am not sure if I'm the one who's lacking understanding of using that 84.26 as the opposite because P and Q are not acting on the same angles. Yes, can I please just get clarity? How is it that we are using the component of P as the opposite for component of Q when they are not acting on the same angles? Thank you, Ntate Nambane. 3.3.2, yes, Ntate Nambala. 3.3, yes, same question, yes. 0.2, yes. Yes. I understand the us using tangent theta, it's understandable. I just want clarity as to why are we using 84.26 as the opposite side if Q and P are not acting on the same angles. Thank you. Yes, Ntate Nambala. Yes. Thank you.
Yes, I follow, sir. Yes, sir.
I just wanted clarity. How does like Q and P are not acting at the same angle, so their horizontal components cannot be the same, because if we are going to use 84.26, we are saying that the horizontal component for P is the same as the horizontal component for Q. That's what I needed clarity on.
Fine. Let me see. Let me just get my thing. So the opposite. If you look at it how you were drawn now,
Meneer,
opposite.
you see, the problem is that the question doesn't make reference to those forces being in equilibrium. So you should scrap that question. Thank you, meneer.
So it's the 50.
Hey, good afternoon.
Afternoon, sir.
Thank you so much, Mr. Nambani. I'm also highlighting just one thing here. We're having forced you, right? And then if we are about to opt for the angle of 50 degrees, which is underneath, we'll be having two unknowns, ne? Or on forced you, because we can't calculate the components because we don't have the actual force. Yes. So if we're about to use our 50 degrees, which is underneath, now it will be saying now the ratio which we're supposed to use is not tan, is not cos, but it will be now sine.
950.
It will be opposite over hypotenuse. Mm. Yes, I believe if we're about to opt for 50 degrees, the angle, now we're supposed to change our ratio from tan to sine. But now it will, yes, it will be sine 50. But now it will be taking us back in the Denamban way, because now we were not told our forces were in equilibrium, right? Because at least they were going to have something in common. Yes, so
And
that
question
it
is
will
not
make
able to calculate.
Thank you so much, Mr. Nambani. So now we'll be having now our one component. We won't be able now to equate our components for forces P and forces Q. Mm. Thank you, Mr.
Ntate Nambani? Yes, I thought Ntate Ndlalankulu, when he uses sine theta, you will have an opposite force. So I just wanted to find out that because the problem is the opposite force. We cannot equate them as equal. Yes. So yes, also the angles are showing that we cannot say they are equal. Yes. Can I move to the next question, the last one? Or
Yeah.
can I please open it to the House to decide if we are canceling it and allocating it to other questions? Or
If we cancel it, then all the other questions must also be cancelled. Then and three. Yes, sir.
yes, I also wanted to say 335 is also asking us to calculate weight, but the memorandum is calculating mass, so it's also incorrect. Ke a leboha.
Um,
I know it's fine. So Ms. Laba dealt with that weight question there. The question is asking for weight, but the memo is calculating mass.
I was thinking now about that opposite, sir. So the opposite, if we look at how you drew it, is on the y-axis, ne? And then the y-axis says actually the adjacent is 70.71 Newton. Oh, sorry. You don't know what's the force. I'm sorry, yeah. Okay, so the okay. So yes, can we leave 2.3 as 1 mark, sir? Because the answers was given, they just had to make a choice. And then by 2.4, we make that 2 marks. because it's an explanation. Yes. And then, Mhm. And then the formulas are by 2.5.1. It's not necessarily for it to be on the data sheet, because mathematically you must know what the gradient is. Yes, sir. Seven, eight, nine. 10. Yeah, it's 10. Mm-hmm. Mm. So can we go back? Maybe we can give for the formulas for horizontal and vertical components. Yes, sir. But then again, you just said now we cannot give for formulas that was not given on the formula sheet. But it's mathematics, so we must know this.
Thank you, Ntate Nambane. Can we please allocate some of the marks to question 2.1, the graph, because they were not given the graph paper. They had to draw the graph, and it's only 3 marks, if it's possible. All right, ke a leboha, thank you.
Question 4. Okay. I think we will see when we go further on, sir. Question 4. A young man is pulling a girl on a sledge with a force of 25 Newton at an angle of 28 degrees to the horizontal, and the coefficient of friction is 0.04. The combined mass of the girl and the sledge is 45 kilogram. 4.1. Define kinetic frictional force, which is the force acting parallel to a surface and opposes the motion of a moving object relative to the surface. There is part marking for the first part, the force acting parallel to a surface, and the second part opposes the motion of a moving object. 4.2. Calculate the normal force experienced by the girl. Fn equals to Fg minus Fy. 1 mark over there. Then substitution, 45 times 9.8 minus 25 sine theta, which is 28, and it equals to 429.26 Newton. 1 mark for the formula, 2 marks for substitution, the first one for Fg and the other one for Fy, and then the answer with the unit, the 4th mark. 4.3, calculate the frictional force experienced by the girl. Fk equals to the coefficient of friction times the normal force. 1 mark for the formula, 1 mark for the substitution, 0.04 times 429.26, which is equal to 17.17 Newton. Third mark for the answer with the unit. 4.4. How will the magnitude of the frictional force calculated in question 4.3 change if the girl is now replaced with a boy that has a higher mass? Right? Only increase, decrease, or remain the same? Explain your answer. So it's increase, 1 mark for increase, The following mark, when the mass is increased, the normal force also increases. Since the coefficient of friction remains the same, the frictional force also increases. So it's 1 mark for increase and the 2 marks for the explanation. You must make sure the last explanation must say, since the coefficient of friction remains the same, the frictional force also increases. Total mark, 12 marks. Mr. Nambani? Okay. Yes. Yes, sir. Sir, I wanted to ask something also. Yes. Um, on the note of not giving a mark for what's not on the formula sheet, I can't remember when it was said like that, sir. But if we are going to look into in terms of a formula that's not on the formula sheet, then if there by 4.2, it loses a mark for the formula, sir. And the children must know, if you talk in terms of a definition, for instance, net force of the of all the forces, vertical components or horizontal forces, when they have to put it in a formula, then they have to break the formula down. So is it going to apply for all the formulas further on? So, okay. Thank you, sir. Question 5. Magnets are objects that produces a magnetic field which can attract or repel certain materials depending on their polarity. 5.1 asks to find a magnet. It's an object that has a pair of opposite poles called north and south pole. 2 marks. 5.2, consider the objects below. Pole X repels pole A. The 2 objects was given there in the scenario, one with north and X and the other one with Y and Z. Sorry, not north, N. 5.2.1 then ask, write down whether Z is a south pole or a north pole. It is a north pole. 5.2.2, give a reason for your answer on 5.2.1. Pole X is south pole and is repelling pole Y. Therefore, pole Y is also south pole. So pole Z is a north pole. 2 marks. Copy and complete the diagrams by labeling the poles and showing the repulsion of attraction between pole X and pole Y. So when they south pole, across south pole, the arrows are pointing towards the poles. Lines do not touch and both poles are south poles. 3 marks allocated according to the marking criteria. What is the relationship between the density of magnetic field lines and the strength of a magnet? As the density of a magnetic field lines increases, the strength of the magnet increases for 2 marks. It's not part marking. Everything must be stated in the answer. So total mark of 10 marks. Yes, sir. Yes, sir. 11. 6 marks. Yes, sir. Thank you, sir.
Thank you, Ntate Nambani. 5.2.3. Yes, my laptop is dead. I logged on with my phone. Can we please award for both poles are south if the learners just said X and Y? Like they got it correct to say it's south south, but when they draw the bar magnets, they continue with X and Y, not south. Yes, that number. Yes. Instead of SS, they continued with YY because they already said that Y is South Pole. Thank you. All right, thank you. Thanks.
Not yes, sir. Question 6 says two charged spheres with a charge plus 2 nanocoulomb and minus 4 nanocoulomb are shown in the diagram below. The electrostatic force between the two spheres is 7,2 times 10 to the power of minus 7 newtons. The diagram has also been given a sketch, and the question starts as follows. 6.1, define electrical field, which is the region on the space in which an electrical charge experiences a force, 2 marks. 6.2, draw the electric field pattern around A and B. We follow the marking criteria. You look at the directions from positive to negative. You look at the shape as shown, and you look at the field lines that do not touch each other for 3 marks. Then 6.3, calculate the magnitude of the electric field of A to B. E equals to F force over Coulomb. Substitution is 7,2 times 10 to the power of minus 7. 1 mark for that substitution. The other mark for the one for Coulomb, 4 times 10 to the power of minus 9, which is equals to 180 Newton per Coulomb. The fourth marks comes there with the unit. Then at 6.4, calculate the distance D between A and B. F equals to K Q1 Q2 over R square. Substitution for force, 7,2 times 10 to the power of minus 7 equals to 9 times 10 to the power. It must be minus 9, Nessa, not 9, because on the table it says minus 9. And then 2 times 10 to the power of minus 9 times 4 times 10 to the power of minus 9 over R square. And then I'm not sure if R is going to change if we change the value of that exponent. So can we just check there on the calculator? Because yes, but on the data sheet, it says 10 to the power of minus 9, sir. Yes, sir. Yes, sir. So the, yes, sir. So then the answer will be. Yes, our data sheet. Yes, sir. Yes, sir.
Sir, the definition, can we please add the a force of attraction or repulsion? Yes, in In the manual, it's a region in space in which the electric charge experiences a force of attraction or repulsion. Can you just maybe add it in brackets for correct signs?
So are we not going to check if we can allocate marks there? Are we going to leave it like that? Okay, no, sir. I think all the marks has been allocated to the purpose that it should be. I just wanted to check, sir. Okay, thank you, sir. Question 7. 7.1 says a learner connects a battery to a lamp using conducting wires. The lamp draws a constant current of 0.8 ampere from the battery for 2 minutes. 7.1.1 define the term electric current, which is the rate of flow of charge. There's 2 marks for the definition. If the word tempo or rate is left out, 0. 7.1.2, calculate the total charge that passes through the lamp in 2 minutes. I equals to Q over change of time. Make sure that the learner did do the conversions for 2 minutes into seconds. So 1 minute has 60 seconds. So we will say 60 times 2, which give you 120 seconds. Therefore, if you do the substitution correct, you will come up to the answer of 96 coulomb. So 1 mark for the formula, 1 mark for the substitution of current, and 1 mark for the substitution of change of time, which also gives 1 mark for the answer with the unit, 4 marks for that total question. 7.1.3, explain what would happen to the amount of charge transferred if the current is doubled, but the time remains the same. So if the current in a circuit is doubled while the time remains constant, the amount of charge transferred will also double. 7.2, learners connect a circuit as shown in the diagram below. Ignore the resistance of the battery and the connective wire. It also goes along with the diagram that has been given there. 7.2.1, define the term electromotive force, the EMF, which is the potential difference across the cell when no current is flowing in the circuit when the circuit is open. So open circuit can be in brackets, especially when the learners wrote no current is flowing in the circuit. Then a total of 2 marks will be awarded over there. 7.2.2, calculate the effective resistance of the parallel formula states how many of the resistors is in parallel, which is 1 over RP equals to 1 R1 plus 1 over R2, 1 mark for the formula. For the substitution, it's 1 over 4 plus 1 over 4. And for the correct answer with the unit is 2 ohm. You will also see there is also a highlighted answer. So if you worked it out correctly, there's a change in the answer. 7.2.3, calculate the total resistance of the circuit. So if there's a change in 7.2.2, there will be a change in the rest of the questions that is following up. So our total is equal to RP plus R3, which makes the circuit a series circuit. Therefore, 2 ohm is then substituted into the equation. 2 plus 2.5 for resistor 3, which is in series, which gives you an answer of 4.5 ohm. Then we move on to 7.2.4. Calculate the total current supplied by the battery, which gives you R total, which is equal to velocity total over current total. Substitution 4,5 for R total equals to velocity or potential difference total, which is 12 over the unknown. The unknown is then the current in total, which is worked out as 2,67 ampere. 1 mark for the formula, 1 mark for the substitution, and 1 mark for the answer with the unit. At 7.2.5, it says calculate the potential difference V2 across 2,5 ohm resistor. The formula says R3 equals to V2 over I total. Substitution 2,5 equals to V2 over 2,67. And then the answer will then be given 6,68 volt. So there's a mark for the substitution and a mark for the answer. At 7.3, they say differentiate between ohmic and non-ohmic conductors and provide each with one example. So ohmic conductors are conductors that obey Ohm's law and have a constant resistor. Example is carbon resistors or metal wire in case of copper or nichrome. And non-ohmic conductors are conductors that do not obey Ohm's laws and resistance changes. Examples can be anything like a filament bulb or a diode or a thermistor or an LED. Total mark is 4 and the total mark for the whole question 7 is 23. Sinambani. Can we allocate marks, sir?
Thank you, Ntate Nambani. I was thinking 7.1.2 because they had to change minutes to seconds. Instead of 4 marks, you should have 5. Yes. Yes. And then 7.1.3 because they are explaining instead. Yes, please.
Yes, sir. Yes, sir. I'm agreeing.
7.2.5 have a mark for R is equals to V over I. And 7. Oh, I didn't see it. That one as well.
Yes, sir. Can leave there.
Or instead of 723, I saw 725. Yes, because it's on the formula sheet.
Yes, sir. Can we leave it for the other questions, sir? Other question. Yes, sir. Yes. Yes. Sir, I wanted to ask something as well. If you can go up to 7.3, ne? The example there that learners can give, they won't necessarily say what type of resistor it is, but they will just say resistor for ohmic conductors. Okay, as a blue note. Thank you, sir. Question 8, sir. Define the term wave. A wave is a disturbance that transfer energy without transferring matter for 2 marks. 8.2, differentiate between a transverse wave and a longitudinal wave. Transverse wave, the particles of the medium move perpendicular to the direction of the wave, which must be across the difference with longitudinal wave, the same, the particles of the medium move parallel to the direction of the wave. Then when you go to transverse wave, has crest and troughs, and then longitudinal wave has compressions and rarefactions. Examples by transverse wave is light waves, waves on a rope, or example is by longitudinal wave is sound wave, slinky, compression wave. The reason why I did it like that is because the differences must be next to each other or across each other according to how they must outline it. So it's 1 mark, 2 marks for one difference and the other 2 marks for the other difference. But it must be across each other. So when we move on to 8.3, in a classroom physics demonstration, a student is holding one end of a slinky while the other end is fixed to a wall or a heavy object. So to create a wave, the student quickly moves their hand up and down, perpendicular to the direction of the stretchy slinky. So as a result of this motion, waves sorry, sir. As a result of this motion, a wave travels through the slinky. In this type of wave, the particles of the medium. Sorry, sir. I just had a call. Can you hear me? Can you hear me, sir? Okay. As a result of this motion, a wave travels through the slinky. In this type of wave, the particles of the medium, the coils of the slinky, move perpendicular to the direction in which the wave is traveling. The image captures the slinky forming a series of crests and troughs as the waves propagates from the hand to the fixed end. The picture also shows what the scenario is stating. So the questions start 8.3.1, what type of wave is illustrated in the above diagram? So it's a transverse wave. 8.3.2, draw a sketch of a wave representing in the above diagram graphically. So if you look at the graphical representation of a transverse wave, you will see that there is no rubric, sir, but I think we can discuss as we move along where we're going to put the marks or allocated the marks. So the y-axis gives the displacement of particles and the x-axis is the distance along the medium. It shows the amplitude, the wavelength, the particle motion, the trough, and the direction of the wave. At 8.3.3, in which direction is the wave moving? Answer left or right. The answer is right for 1 mark. Then at 8.4, there is a diagram that was given there. The following diagram represents a wave with a frequency of 20 frequency hertz. So the diagram has been given. It shows 30 centimeters from the crest to the trough, on top to the bottom. And then over a period of 2 waves, it shows the wavelength of 3 meters. And then there's points on the waves that has A point, B, D, and C. So 8.4.1 asks to find the term wavelength in words. The wavelength is the distance between 2 successive corresponding points on a wave, for example, between 2 adjacent troughs. 2 marks for that answer. 8.4.2, identify which point A, B, C, or D represents. Then the crest represents B and the trough represents C. 1 mark for each points. 8.4.3, use the diagram to determine A, the amplitude of the wave is the 30 divided by 2, which is 15 centimeters. And then there is also a conversion divided by 100, which is 0.15 meters. Make sure the unit is also at the end, which gives you a set of 2 marks. 1 mark for working out, 30 divided by 2, and 1 mark for the final answer, to show the conversion. The wavelength of the wave is, the sign there is a lambda, which is 3 divided by 2, as you can see in the diagram. It equals to 1,5 centimeters, also a conversion of 0,15 from centimeter to meter is divided by 100. 1 mark for the workout, 1 mark for the answer for the unit. The period of the wave, T, is a capital letter T, equals to 1 over frequency. Substitution is 1 over 20. Answer is 0,05 seconds. 1 mark for substitution and 1 mark for the answer. D, the speed of the wave, V equals to, velocity equals to frequency times a wavelength, which is substitution 20 times 1,5 meter, which is equal to 30 meters per second. 1 mark for the formula, 1 mark for the substitution, and 1 mark for the answer with the correct unit. A total mark of 3 marks for that question, which gives us a total mark of 23. Thank you, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Okay, question 9. When a piano, sorry, sir, there is a question here by 7.2.2 on the chats. I don't know if you will see it there, sir. Or 7.2.2. Mhm. Thank you, sir. Thank you, sir. Question 9. When a piano produces a sound frequency of 4,187, is their hand?
Afternoon, Tate. 8.3.2, we still need to allocate marks for the graph. 8.3.2, yeah, the criteria.
I think.
I,
I was thinking, let's look at the shape of the waves that they draw. Maybe 1 mark for that. Yes, sir. For the direction. Yes, sir. I agree. Yes, sir.
thank you, sir.
Okay, question 9. When a piano produces a sound frequency of 4,187 kilohertz, it corresponds to the note C8, which is one of the highest notes on a piano keyboard. The diagram below shows the vibrations of a piano string. It shows also the distance between point P and point S, which is 300 centimeters. 9.1, define a longitudinal wave. So it's a wave in which the particles vibrate parallel to the direction of the propagation of a wave, which is 2 marks. 9.2, write down 2 letters that represents the following. Refraction at 9.2.1, which is QS. 9.2.2, compressions, which is PR. 9.2.3, a wavelength, which is PR or QS. 9.3, calculate the following for this wave. 9.3.1, period, which is a capital letter T equals to 1 over F. Substitution 1 over 4,187 times 10 to the power of 3. We must show the conversions over there, and then gives an answer of 0,00024 seconds. 1 mark over there with the unit. 9.3.2, speed. The conversion was made 300 centimeter to meter. You divide it by 100, which gives you 3 meters. Then the wavelength you calculate and you divide it to 3 over 1,5, which is 2 meters. Then you use the formula of the wave, V equals to lambda times frequency. Substitution correctly, 2 times 4,187. If you took it out of the exponent form or scientific notation, then you get 8,374 meters per second. So 1 mark for the 3 over 1,5, 1 mark for the answer with the unit, 1 mark for the formula of the wave, 1 mark for the substitution, and 1 mark for the answer, which equals to 5. 9.4, a speaker placed 136 meters away from a wall produces a sound. The sound reaches the speaker again after 0,8 seconds. The speed of the sound on air is 340 meters per second. There's a clue there which tells you what the scenario was speaking about. 9.4.1, property of sound is responsible for the appearance of an echo, which is reflection. 9.4.2, what would happen to the time delay if the reflecting surface was closer? Write only increase, decrease, or remain the same. It is decrease. 9.4.3, by means of calculation, prove that the speed of sound on air is 340 meters per second. There's 2 options. Option 1, velocity is equal to the change in the distance over the change of x over change over t, which is 136 over 0,8 divided by 2, because it bounces back, and it gives you 340 meters per second, not per square second. Per square second is acceleration. Please take a note there. Then option 2 will also use the same formula with a substitution of 136 divided by 0,8. And when there is reflection, it goes over the area and come back the same area. That's why the 2 is over there. So you times it with 170 and gives you 340 meters per second. So 1 mark for the substitution in option 2, second mark times by 2, and the third mark for the answer with a unit. Total mark of 4. The whole total mark for question 9 is 19. Mr. Nambani. Thank you. Distribution.
Thank you, Ntate Nambani. Can we distribute at 300 over 100 to 3 meters? 9.3.2. Sorry.
Yes, sir. Yes. Total 150. Thank you, sir.